Okay, so for this question, we're trying to see if this formula over here is valid under structure M. And structure M is given in the question. So for a formula to be valid under a certain structure, it has to be satisfied for any valuation rho, which just means that for any valuation you have, the formula is still true. So first, with this sort of question, I think you should just look at the formula and think about what it means to get some intuition on whether or not it's true. So x and y here, they just represent natural numbers, right? So integers starting from 0 and going to infinity. So the first clause just says that x is less than y. And the second one says that x is greater than y. So either x less than y or x is greater than y. And this is the same as saying that x and y are different. So if x is less than y or is greater than y, then they're not the same. So x and y are different. And this over here is saying that x and y are the same. So if you take these two clauses and take this one, we get that this formula is essentially just telling us that either x and y are different or they're the same. So if you think about this, it's obviously true. So any two numbers are either going to be different or they're going to be the same, which means this formula is in fact valid. We just have to prove it mathematically. And to do that, we just need to follow the definitions that they give in the slides. So these are the definitions over here. So what we do is we start from bottom to top and we apply all definitions we can. So looking at the bottom, do we have anything from here? So we don't have existential quantifiers, we can skip that. But we do have universal quantifiers. So we need to apply these definitions. So we say that this, if and only if, so the same as in the definition, if and only if m turns tau rho, and then we can choose like a variable for x to go to. So we can say x goes to n. Sorry, it's not a variable, it's an element of the domain. So we say x goes to n for all y. Then look at the definition, which we say for all n in natural numbers. So natural numbers is the domain of the model, which is why we're using here. Okay, we've done one thing, but we still have another universal quantifier. So we apply the definition again. So this is definition 2. Then we say for all n, m, and n. And you can use any letters you want for this, as long as it's not already in the formula. Okay, so we've done all the universal quantifiers now. So again, looking from bottom to top, do we have any by implications? We don't. Do we have any implications? We don't. But we do have disjunctions, which are over here. We have 2 of them. So we just apply the definition again. So the definition is this thing over here. So we just need to apply that. So we'll do this one first. So this thing over here. So this turns into m rho then we have x less than y, or So in this case, if we look over here, we have A and B, right? So in this case, A will be x less than y, and B will be y less than x. So that's like what we're applying the definition to over here. So it will be the same thing, but for y less than x over here. Then y less than x. So we've done it for these two things. We just have to do the same thing for this one, for the final disjunction. Just say or m, comma, turnstile. This always gets really messy in the exam, by the way. For all n, m in the natural numbers. Okay, so now we've taken care of all the disjunctions in the formula. So we can cross that out. We can move on to the next thing. So we don't have any conjunctions, or we also don't have any negations, which means we move on to the very final definition we need to apply. I'm just going to move it down here so it's easy to see. Okay, so now we take, so this P represents a predicate, and the stuff inside are just the terms. So for example, we have x less than y. So in this case, this is the predicate, and these are the terms. It's just written in infix notation. So this is the same as saying this, right? So if you look at this, in this case, P equals to this, and then T1 and T2 will be x and y. So we just apply the definition in this way, like this. So that goes away. We just have rho, a tuple, and you have to like keep rewriting all this like x to n and y to m stuff. It's really annoying, but you have to do it. So just like we did like yesterday, you have to put the stuff in tuple form. So this is the bracket for the tuple. And tuple is just the thing where you like show them like this. Then we have y. So according to the definition, this will be an element of the predicate, which is the less than symbol, under the structure M. So we've done this thing over here. We've done this thing. Now we need to move on to the other ones. Just do the exact same thing. So this becomes or rho of y, comma rho of x is an element of the predicate symbol, which is just this. Okay, so we've done two of the clauses. Now we do the very final third one. So or the exact same stuff. So it's just really repetitive. But if you do this enough times, you like be able to memorize all the definitions, and it'll be really easy. But it does get messy. So also our demons to this. I'm just gonna move this over because it's taking up a lot of space. just again, the formula that we're doing is x equals to y. P, the predicate, will be the equal sign, and then this will be t1, this will be t2. Then these two things as a tuple will be an element of the predicate, which in our case is the equal symbol. Okay, so we've done all the definitions, which takes us to the final step. So in the exam, you'd want to translate this to English. So you could say that this is if and only if only if all pairs of numbers, so natural numbers, are either different or equal to one another, which is true. Therefore, it is valid. So I know it's a bit messy, but like the final formula that we end up with is this thing over here in red. So it's on several lines because it's super messy, but this is the thing we end up with. And then you just need to sort of translate that to English and sort of explain in English why this is true. And that's it. But as long as you do like this definition stuff, you'll get like 80% of the marks at least. This final thing isn't too important. Okay, I think that's it.